Welcome to the JGI JCE eConnect classes. So hello all, here we'll be starting with an important concept of why the big data is necessary. Why this big data is necessary, it was the question. So in the earlier video we have discussed the importance of why or what is the basic need of a big data analytics, what do we mean by what big data, how to process it, what all things are required. So without wasting time, let us start discussing about HDFS file system. So what is a big data analytics? It is always dealt about a huge data storage which process a stored data and it draws the conclusion from the processing of the data, which is nothing but analytics. Big, huge data analytics which we have to process on the data and get the conclusion. It examines a large amount of data to uncover the hidden patterns, correlation, and other insights. You people might have observed the things when you have seen during certain cricket matches. It tells how a particular player plays. If he would have played in different angle, what all the opportunity that a particular bowler, a particular batsman has got it. Okay, so there are a lot of things, and these are depend upon actually the whole big data, its need and its operation is depend on these 5 V's concept, which we have already discussed in the previous video. Once again, I'll just revise what this 5 V of big data. The volume is nothing but size of data, but people used to say it's size of data, but it is many points are there other than the size of data. It is not only GBs. Maybe you, when we deal with the things, you get to know what is actually the size of a data. When we discuss about the volume, okay, the velocity, the speed of data generation, we know the nowadays if you consider any social media, let's just like Twitter, Facebook, every minute crores of tweets or crores of comments comes on a particular post. So you can imagine the kind of the kind of the you can say the kind of number of tweets which are coming. So how much it is getting populated, how to produce or how to operate on such kind of data. The speed is very high, and it is not only the kind of structured data or semi-structured data, it is unstructured data also. So variety is also one of the very important thing, because processing the structure, maybe sometimes some semi-structured, is very easy. We can understand this is a particular format. This particular column is only handling, say, numbers pattern. This is handling the textual pattern. Another column may handle the combination. And the processing along with that, we can use the pattern matching concept to understand to process the data, which is very easy. In the same way, semi-structured data also, when you consider the examples of a email. So first part will be the header, where the information related with the sender, receiver, and some other information will be there. But when you consider the unstructured data, just like your images, say MP3 files, where you hardly have any kind of pre-information, so you cannot say at what part of the data will be kind of another type of data. It cannot be same. It is a every bit of that information has to be processed. So it is a variety also. And if you see, it has a lot kind of inconsistency and uncertainty in the data. As I mentioned, we cannot say at what particular part of the data which we are going to process is definitely you cannot say it is belongs to what. So there will be inconsistency. Sometimes you need to pre-process the data. So there is a requirement when we are dealing with machine learning. There are a lot of techniques which is required to be implemented to pre-process the data. And finally, the important part of the analytics, it is a conclusion drawn, the value. So these are the 5 V's we have supposed to. Now this is about the big data. Now what is this Hadoop or HDFS? This Hadoop distributed file system is one approach to store the big data. Right now we have seen a lot of amount of data, which we used to call volume data, has to be stored somewhere, right? Generally we have seen the kind of structured example. If I say the Excel file, we require Excel, a file to be stored, right? Any data in an Excel file. Semi-structured data, maybe the mails, it has to be stored in some way, somewhere. Unstructured also, maybe. So how this has to be stored? So we require one file system. For that, we have a Hadoop distributed file system. Is one approach to store that data. It's just meaning is to store the data, just like your Google file system. Actually, most of the part has come from the GFS only, Google file system. Okay, now here what actually we are doing. So before going ahead, we'll see some of the silent features of Hadoop files, HDFS. So how this works? Okay, so in this Hadoop file system, if you see, there are the certain features that we'll be discussing, and this can be asked in the university examination for 4 to 6 marks. It is designed to big data processing. It has a capability of supporting many users simultaneously. So parallelly it works. HDFS actually is not designed as a true parallel file system. Rather, the design assumes a large file, and very important concept, write once, read many model. People generally consider it as a parallel solution, but actually it is not. It is write once, read many design is intended to facilitate streaming reads. So once it has been written, so many people can be reading the data simultaneously. So people think it as a parallel, but it is not. It is just a streaming read concept. Okay. So HDFS rigorously restrict data writing to one user at a time, because there will be the problem that kind of data may get changed. One user might be writing some other things at the same time if another user is writing. So there will not be the same data will not be written. So at a time a resource will be given to one user only. Bytes are always appended to end of the stream, and byte streams are guaranteed to store in the order written. The design of HDFS is based on the design of the Google file system. As I mentioned, it is uh, GFS data which we have to consider. And generally what happens, HDFS is designed for data streaming where large amounts of data are read from disk in bulk. The HDFS block size is typically, I'm mentioning the size, the block size is typically 64 MB or 128 MB. This approach is unsuitable for standard of POSIX file system that is to be used. I hope you people are aware of the POSIX. So for these kind of small block sizes, it is unsuitable for this kind of things. Okay. I just wanted to explain some more things about it. Due to sequential nature of data, there is no local caching mechanism. The large block and file sizes makes it more efficient to reread the data from HDFS than to try to catch the data. it has no local caching mechanism. Okay, so generally a reliable file system maintains multiple copies of data across the cluster. A principal design aspect of Hadoop MapReduce is the emphasis on moving the computation to the data rather than moving the data to the computation. Moving computation is cheaper than the moving data. See, the main concept to have these HDFS is to make this system is cheaper. How to make it cheaper? So instead of moving the data, we are moving the whole computation body to the data. We are processing itself there and we are giving it back. Just like if I give an example of a catering people. So if there is any function at your home, you need not to go to the caterer wala people and give all your things and get it done and come back and take all the things what has been prepared and serve at your food. What people generally they used to do, they ask the catering people to come at their home. They give the materials, raw material. They prepare at their home only where the function is going to happen. And once the food is prepared, as the function is there only, it is very easy. So it is moving computation is cheaper than the moving data. So this is a basic thing which makes the computation very at faster rate. Okay, this is a very important technique which we have seen. Reliable file system maintains multiple copies of data. What happens? Why it is so? Actually, failure of single will not bring down the file system. Okay. Now let me take you this is the silent features of HDFS which will be asked in the examination, which may be asked in the examination for 4 to 6 marks. Another important concept and question may ask is the discuss the various system roles in HDFS components or deployment. This second question may ask for 6 to 8 marks, and in this two things are very important which we will be dealing in the next couple of slides. Okay, so it is basically we have to say about how these HDFS components are and their deployment and what are the system roles are going to happen over here. So let me directly start. Here basically there are the two types of node that we are going to deal. First one is the name node, which basically called as a master, and data node, which is going to be called as slave. Now if you are going to see, we have given the name as one of the node as a master and another node as a slave. So we have seen in the previous other subjects the master slave architecture, the master slave, in which a master has the control over the slaves. Okay, so we are going to do the same thing. Now what happens in the master? Master holds the metadata. Metadata is nothing but the data of the data. It may not be the actual data. Okay, it file system namespace. So what it does, it is opening the data or opening the file, closing the file, renaming the file, maybe the directories also. It manages the block creation, deletion and replication also. What is the block will be dealing in the further part. It maps the block to the data node, handles the data node failure because it is a master. If any data node which it going to have a control over that, if it get failure, it handles, because that operation has to be which the response which has given to the particular data node, and if it is got failure, it has to be given to somebody else. It manages the client. So actually the client basically first connect with the master. It is the job of a master to divide the work and give it to the different data nodes. Now what data node actually do? Data nodes actually holds the data on which whatever the responsibility, whatever the data is given by the client, it actually works on the actual data, these data nodes. It serves read or write requests from the file system to clients. The name node actually in real life, it works as a manager, while the data nodes are working as an employee under the manager. So basically what we used to say, the data nodes hold the actual data, which processes the data. The work of the name node is to distribute the work among other data nodes. Now actually we'll be seeing how this is thing, which you have to draw as a figure if this question asked in examination, which gives you on the 5 to 6 marks. Now what happens here? So if you are able to see what is happening here, see, the name node manages all the metadata needed to store or retrieve the actual data from the data node. Here if you are able to see, the client is connecting first to the name node, where client is just take an example, where do I read or write the data. So name node is saying use these nodes. So meantime what happens, this name node has given the information to the data node. Along with the name node, there is another secondary name node which is only for the backup. And here if you are seeing the HDFS data, which has in the example we have shown as only 3 data node, but if you are able to see, there is only one name node which is been connected to all the 3 different data node. But what is the job of secondary name node? It is just a backup. Generally we are actually in working only one name node. There can be multiple data node. The another secondary name node is for only backup. So what happens, we are distributing, means name node is distributing the work to the data node, and here name node is asking now, okay, now these are the people with which you have to work with the client. So now actually client and data node are working together, means they are reading the data, writing the data, the communication has happened between the client and the data node. So what was the job of a name node? That is a very important question. So name node is first connecting to the client, understand the problem, then distributing the work to the respected data node. Once distributed, now the client and these data nodes can communicate. So this is how the HDFS works. The design is a master-slave architecture in which master, that is name node, manages the file system namespace and regulates access the files by client. So what happens here? The file names, a file system namespace such as maybe opening, closing, renaming the files, all are managed by the name node. Okay. The name node, actually, one more important thing I wanted to discuss. The name node does not write any data directly to the data node. If you are able to see the connection which I have shown from the name node to the data node, it does not have any pointing saying that read or writing. Okay, so it does not write any data directly to the data node. It does, however, give the client a limited amount of time to complete the operation. If it does not complete in the time period, the operation is getting cancelled. Okay. The client requests a file from the name node, which returns the best data node from which to read the data. The client then accesses the data directly from the data node. Thus, once the metadata has been delivered to the client, the name node steps back and lets the conversation between the client and the data node proceeds. While data transfer is progressing, the name node also monitors the uh, the name node also I can say the name node also monitors the data nodes by listening for heartbeats sent from the data nodes. There are the certain heartbeat signal which indicates a node failure. So that is a job of a name node which understand if any of the data node gets failure, so that heartbeat signal will be zero, and it understand that it is failure, so it can assign the same job to different name data node. It is a job of name node. Okay. So the lack of heartbeat signal indicates a node failure. Hence, the name node will route around and fail around the failed data node and begin replicating the new missing blocks. The mappings between data blocks and physical data nodes are kept in persistent storage on the name node. The name node stores all metadata in memory. The actual metadata will be with the name node, so that the name node and this data node has to communicate. In almost all Hadoop deployments, there is a secondary name node, which is also called the checkpoint node. It is not an active failover node and cannot replace the primary name node in case of its failures. So actually, what is the basic thing it has that we have discussed till now? Okay, the main thing, what are the basically what we have seen over here. HDFS is a master slave model. The name node is a metadata server or data traffic cop, I can say. It provides a single namespace that is managed by the name node. Data is redundantly stored on data nodes. There is no data on name node. Secondary name node performs only the checkpoints of name node file, but it is not a failure node. So these are the basic thing where we have seen the storage of metadata, how it works. The data node provides a report on blocks once in every 10 heartbeat signals to name node from its persistent storage. This is going to enable to keep an up-to-date account of all data blocks in the cluster. Name node updates mapping between the data blocks, which we have already discussed. Yeah. So these are the name node has to track changes of the metadata. So FS image, edit. These are the file system which we are going to do. The summary also, we have seen how it works with the different things. These are the 5 important summary points. Now another and important thing is HDFS block replication, which we have already discussed how this HDFS block replication plays an important role. So whenever HDFS writes a file, it is replicated across the cluster. We have seen there will be clusters has to be made to store the data. So whenever HDFS writes a file, it is replicated across the cluster. This is the reason for data redundancy in HDFS. So when we are replicating, the data might be redundant in HDFS. And now you may say, sir, the data is getting redundant, whether it is good or bad, storage will be there. So I'll come to the both the parts. If data is getting waste or the storage is getting wasted because by storing the same file at different places, right? But how it works? So the amount of replication is based on the value of DFS replication in the HDFS site.xml file. You'll get to know about this. Hadoop clusters containing more than 8 data nodes. A replication value is set to 3. You know, to represent 8, what is the bit size you require? The number of bytes? Yeah, it is 3. Very good. To raise to power 3. Okay. So Hadoop cluster of 8 or fewer data nodes, but more than one replication will be set to 2. I think you got the concept. For a single machine, replication factor is 1. If a file is 80 MB or is returned to HDFS, 64 MB, that will be the block size, or you can say 60 MB blocks are created. Now let us take an example of this, what happens here. Yeah. Now, if several machines must be involved in serving a zero file, then a file could be rendered. So here I'll tell you one example. You can see here 64 MB blocks where 1, 2, 3, 4, 5, these are my block numbers, and these are the different uh, data nodes where these blocks are getting stored. So if you are considering the first, I have considered 8 blocks here or 8 data node. To represent 8 data node, I said we require 2, right? Yeah, we require 2 numbers, a set of 2. Yeah. So in the first data node, we can see 1 and 3 block is being stored. In the second data node, 3 and 4 block is saved, stored. In the third one is third and fifth. Fourth one is first and fifth. Then in the fifth data node, only one we have stored, that is the second file, second data file, and in the sixth, 2 and 5. In the next one is 1 and 4th, and last one is 2 and 4. Now, if you are able to see, there are the certain data is been replicated in every block. I had only 5 data files, and if you are able to see, as I have a 8 data node, the data files has been replicated. Yeah. So what happens here? When a name node starts, it enters the read-only safe mode where blocks cannot be replicated or deleted in the safe mode. Okay. Actually, it enables two important processes that is to be performed by name node. First one is previous file system, which has been reconstructed by loading FS image file into memory and replying that edit log. Second, it checks mapping between the block and data node is created by waiting for some, maybe for enough of the data nodes to register so that at least one copy of the data is available at that moment. HDFS can also enter this mode for maintenance using HDFS DFS admin safe mode command, or whenever there is a file system issues that must be addressed by the administrator. Uh, if you see, these are very important points which we have discussed now. It deals with the data locality also. Typically, Hadoop cluster will exhibit 3 levels of data locality. Actually, we are talking about the rack awareness, which is very important concept in the further part. It resides in the same rack better. Data resides in a different rack, maybe the good. But if data resides on the local machine, it is the best opportunity for the data locality. You know the yarn, which is scheduler, is assigning map reduce containers to work as a mapper. It tries to place container first on the local machine, then on the same rack, and finally on another rack. A default Hadoop installation assumes all the nodes belong to the same or large rack. Another and very important point of the feature is name node high availability. This name node should have a high availability. If it is not been available, it cannot communicate with the data node, because data node are the main node which does the operation over here. So earlier name node was a single point of failure that could bring down the entire Hadoop cluster. In I must say, in order to provide true failure service for name node, it should be high availability to be implemented. Generally, what happens? The hardware which is being employed redundant power supplies and storage to guard against such problem. In a name node, there is a cluster has two separate name node machine. So one will be in active state, another will be standby state. So what happens here? I'll explain you with the example. You can see. I have another standby node and one is active node. So these are the at the first level there will be journal nodes which are available, and the in between part there will be active node you can see here and standby node, and at the last you can have a can able to see that there will be some parts of the data nodes, but actually only the active name node writes errors. The standby name node reads edit from the journal and also acts like a checkpoint node, which I have already explained in the previous part. The standby node or the secondary name node which only working for the checkpoint node. What happens? The HDFS state is shared by the quorum or of node, and this data node are report to both name node but finally take orders from the active one only. The data node always has to get communicate with the both active name node as well as standby name node, but the operation or the orders has to be taken from active name node only. Okay, maybe I'll share in short. These active name nodes responsible for all the client HDFS operation in the cluster. Standby name node maintains enough state to get whatever heights plan you can see in the same slide. So I hope you will be going through this. Okay, now there is one also example which I have to consider about the zookeeper. This is also monitors the name node health also zookeeper. It highly available services for maintaining small amounts of coordination data, maybe notifying clients of charges in that data, and monitoring the clients for failure. If HDFS failure relies on Zookeeper for failure detection and for standby to active name node in action. And not but the next one is name node federation, which we are going to consider is the older version for the HDFS provided a single namespace for entire cluster, which is managed by a single name node. So what happens? The resources for the single name node determines the size of the whole namespace. The federation addresses the limitations or by adding support for multiple name nodes. I feel the key benefits for the having this name node federation are the scalability, namespace scalability. It makes sure that it gives the better performance and the system isolation. How it is? So let's take an example and understand the name node federation, how it actually works with this. So this name node 1 and name node 2, they are dealing with the data node. Say name node 1 with the namespace 1, which has storing the metadata, the research and slash marketing, whereas the name node 2 with namespace 2 has the data maybe in the data there is a project folder. So name nodes do not communicate. They simply manage their slice of the namespace. And the data nodes can store blocks from any name node. I hope you are understanding this federation. Okay. Last few slides I wanted to explain the checkpoints, backups, and snapshots and the gateway. So we will be dealing with this. The back checkpoints and backups. We know we have used the name node 2 which also means to work as a checkpoints and for backups. So HDFS backup node maintains an up-to-date copy of the file system namespace both in memory and the disk. Since it has an up-to-date namespace stored in memory, it need not to download the FS image and edit files from active name node. A name node supports one backup node at a time. No checkpoint nodes must may be registered if backup node is in use. Okay, so it has an up-to-date namespace state in memory. May not be needed to download the FX image. It has already that file with the active name node. Okay, and once your backup node is in use, you need not to use the checkpoints because name node supports one backup node at a time. Okay. Now about the snapshots, we know what the snapshots does. It generally created. It is generally created by the administrator using the HDFS snapshot commands. The read-only point in the copies. Okay, so maybe it basically has the certain features that is taken a subtree of the file system. Then it can be used to data backup, protection, and recovery. It creates the instantaneous and it has to record the block list, maybe the file size, and do not adversely affect on regular HDFS operation. So snapshots is very important, which gives the information about which stores or record the block list of the and the file sizes. So whenever there is a mismatch of the data at a name node or maybe another location, so we have to come back and check the snapshot and we have to match. So snapshots, because we are dealing with the file system, file storage, so we should understand where the data, how the data, if it is getting lost, how to retrieve back. So snapshots plays a very important role to understand this concept. And the gateway, yes, the last point in the HDFS NFS gateway, it actually supports the version 3 and enables HDFS to be mounted as a part of the client local file. It has certain features that it can easily download or upload files from the file system, from their local file system. Means from HDFS file system to local file system, it can easily download or upload the data or files. Okay, and it can use to stream data directly to HDFS through the mount point. Now with this, we have finished around these basic chapter 1 which gives the basic information about what is HDFS file system. In the next part, we'll be dealing with the commands which is helping us to retrieve the data to communicate with them. So stay tuned, we'll be dealing